Okay, so in the last section we learnt about how the carbonyl group react with the Grignard reagent, and here are some more examples of how other types of nucleophiles react with carbonyl compounds. For example, we have acetylide ion, and then in the presence of sodium amide NaNH2, it's a base. The base grabs acidic hydrogen from the acetylide ion and forms this carbanion. Okay, and this carbanion now can act as a nucleophile and react with the carbonyl carbon, and then the pi bond opens up. Now you know the process. It generates the intermediate oxide ion, alkoxide, and then when you add a protonated pyridinium ion, it can protonate to give you an alcohol. So starting from an alcohol, not alcohol, starting from an aldehyde with the acetylide group, so we were able to add a triple bond to the carbon. Okay, so if you know what you want to get by knowing different types of reactions, we should be able to achieve the product that we want. Reaction of aldehydes and ketones with cyanide ion. Similar to the previous one, now we have, instead of a acetylide ion, now we have a cyanide ion that can act as a nucleophile. It attacks to the carbonyl carbon and then form the cyanohydrin. Okay, you know what to expect. And then oxygen grab the hydrogen, cyanohydrin. And here's the mechanism. Cyanide ion attack the carbonyl carbon, pi bond opens up, and then generate the alkoxide anion, grab a proton, and then completes the process. And we call this molecule as a cyanohydrin. This is the cyano part, and then the water part, and it's called cyanohydrin. And this cyanohydrin can undergo many different reactions with different reagents. For example, if you have a base like hydroxide, sodium hydroxide and water, so this can decompose and give back the original ketone that you began with, because the hydroxide can go and grab the proton from the alcohol, because alcohol is acidic, create the alkoxide anion, and then it reforms the carbonyl group and leaves cyanide group, giving back the original ketone. Okay, and then if you have this cyano group or cyanohydrin, you heat it with hydrochloric acid and water, and this cyano group will become hydrolyzed, giving you a carboxylic acid. So you have a carboxylic acid, and in the alpha carbon you have an alcohol group. We call it as alpha hydroxycarboxylic acid. Okay, and then for the same compound, cyanohydrin, you add hydrogen with Raney nickel. Excuse me. This is a hydrogenating agent, so that will give hydrogens to carbon and nitrogen, giving you a primary amine. So reduction to a primary amine with an alcohol group on the beta carbon, alpha beta on the beta hydroxyamine. Okay, and another very popular reaction is reactions of aldehydes and ketones with hydride ion. So the source of hydride ion is a reagent called sodium borohydride. Okay, so this gives H minus ions. For example, if you have an aldehyde in the presence of sodium borohydride, it will add one hydrogen to this carbon, and then this will make it alcohol, OH. So aldehyde will become a primary alcohol with one carbon. You see this part now? It is a reduction. If you recall, what is a reduction? Reduction is addition of hydrogen. So you are adding hydrogen. And oxidation is addition of oxygen in organic chemistry. Okay? So this is a reduction. Aldehyde will give you a primary alcohol. And if you start with a ketone, sodium borohydride, the nucleophile here is going to be hydride, H minus. So the H goes here, and this will become OH. Okay, if it is a Grignard reagent, remember it was alkyl group that add on to the carbon. Now here the hydrogen, so now it became a secondary alcohol. Let's look at the mechanism. That's the fun part. So this is your sodium borohydride. Boron and hydrogen bond breaks, and then the hydrogen will carry the 2 electrons along with it as H minus, and form a bond between the carbon and hydrogen. So you know the process now. Pi bond opens up and became alkoxide ion. So this is the first step. And after this first step is completely done, then you add acidic water, acid. So then the acid will help you to protonate the alkoxide ion and get the alcohol, a product of nucleophilic addition. Okay. And similarly, acyl chlorides also react with hydride ions. So this is a acyl chloride. So this group is called acyl chloride. With sodium borohydride, it in fact reacts 2 times, because now we have a good leaving group over here. Okay, so you can see this would become a primary alcohol. It first leaves this. Okay, let's look at the mechanism. Here, acyl chloride, this is what happens. So this is your borohydride, similar to what we had seen before. Boron hydrogen bond breaks, gives its electrons to carbon, open up the double bond, breaks the pi bond, and you create this tetrahedral intermediate with the chlorine. A group is eliminated from the tetrahedral intermediate. If you had an aldehyde or a ketone, this one would be carbon or hydrogen. It would not leave, but the chloride here is a good leaving group, so you can reform the carbonyl group and leave chloride. So you are getting an aldehyde here. Okay, now we know aldehyde react with sodium borohydride, similar to the last slide that we saw. So you would not stop here when you use sodium borohydride. So the second addition of hydride take place. It attacks the carbon, open up the bond, forms the intermediate, and when you add the acid, it gives you primary alcohol. Okay, so the acyl chloride will give you primary alcohol. Ester will also do the same. Okay, a weak hydride donor stops the reaction at the aldehyde. Now, when you have a acyl chloride with the sodium borohydride, because it's strong reducing agent, it gave you all the way to a primary alcohol. It did not stop at the aldehyde level. Okay, but if you can reduce the strength of the sodium borohydride reagent, then there is a possibility that we can stop the reaction at aldehyde. To that, we can use this reagent. This reagent comes from another reagent called lithium aluminum hydride. Lithium aluminum hydride. So sodium borohydride, we have seen that. Another one is aluminum borohydride. Basically, there are 4 hydrogens on. No, that's not the one. I wrote the wrong thing. That is LaH, lithium aluminum hydride. Lithium aluminum hydride, the other type of reagent. So there are 4 hydrogens on aluminum. They are going to be very reactive. But if you reduce the amount of hydrogen, you're going to be replacing those hydrogen with some alkoxy groups and then keep only 1 hydrogen. And you carry the reaction at a very, very low temperature, negative 78 degrees Celsius. At that point, you can stop the acyl chloride reduction at the aldehyde level. Okay, replacing 3 of the hydrogens of lithium aluminum hydride with OR groups. So these are the O and R groups, makes it a less reactive reducing agent than sodium borohydride. So if you want to stop acyl chloride at the aldehyde without going all the way to primary alcohol, we use this lithium aluminum hydride reagent that is replaced with 3 alkoxy groups. And then the second step is you are adding water. Okay. And then the reactions of esters with hydride ion. Now ester reaction also similar to acyl chloride or acyl halides, having a chlorine here. So with lithium 2 lithium aluminum hydride, so the two hydrogens will come to this carbon and form a primary alcohol. And the mechanism is similar to acyl chloride with sodium borohydride. So this is the ester aluminum hydride. Hydride part comes from breaking the aluminum and hydrogen bond. Attack the carbonyl carbon, pi bond breaks. So now you have this tetrahedral intermediate. And then there is a group that you can eliminate. You are not breaking a carbon-carbon bond. You are breaking a carbon-oxygen bond, which is much more feasible than breaking a carbon alkyl group or carbon hydrogen. So the pi bond reform, forming the aldehyde, and you leave the methoxide group, methoxide. And the second hydrogen from the aluminum hydride reagent attack the carbon, and then this will be added on to the carbonyl carbon. Pi bond opens up, you create this intermediate RCH2O minus. And then when you add the acid in the second step, we can create the primary alcohol. Okay. Now, if you have an ester and you want to stop the reaction at the aldehyde level, we can use dibal H. Dibal H is this reagent right here, where aluminum has this dibutyl group attached to it. Dibutyl group, so 2-butyl group. Diisobutyl, that's the dibal stand for. Diisobutyl groups attached to the aluminum. And then you have hydrogen. So dibutyl aluminum hydroxide, aluminum hydride, is again a milder reducing agent because it has only one usable hydride here, and then you have aluminum attached to isobutyl groups. Again, the reaction is run at negative 78. So ester can be stopped at aldehyde level when you have this milder reducing agent, dibal H, used. Okay, and this is dibal H, diisobutyl aluminum hydride. This is isobutyl group. Iso part is this 4 carbons, isobutyl, diisobutyl aluminum hydride. Okay. I have used these reagents during some of the reactions I did in my PhD, diisobutyl aluminum hydride, have used sodium borohydride, and they work well. They're good. Reactions of carboxylic acids with hydride ion. Now, how a carboxylic acid react with lithium aluminum hydride. So what do we see here? We have a carboxylic acid with lithium aluminum hydride. Again, you can see this is going to reduce all the way to a primary alcohol. Okay. This is the mechanism. Now, when you have a carboxylic acid, now in the earlier examples, the hydride attach the carbonyl carbon. But when you have a carboxylic acid, this hydrogen is more acidic, that would be removed by the hydride ion. H minus take this acidic hydrogen and form hydrogen gas. And then this forms this intermediate where you form a pi bond between the carbon and oxygen, and this carbon and oxygen double bond will become now a single bond. Okay, and then since it's a O minus, the resulting ion would be the counter ion for this oxygen. And also it can form a bond between oxygen and aluminum, because aluminum now has 3 bonds. Earlier it has 4 bonds. And then aluminum will carry a negative charge since it has 4 bonds. Okay, 3 minus 4, negative 1, according to the formal charges. Now what happened? a new hydride donor, this one. Now another hydride ion will react with this carbon and then open up this pi bond. So here this aluminum now has 3 bonds. So one of these 3 hydrogens can act as a hydride ion, okay, and give its electron to this carbon, and then pi bond will open up and you're going to form alkoxide ion. So you see this aluminum will now end up having 2 hydrogens, and 1 hydrogen has given to this carbon, that's this hydrogen, okay. But this is an unstable tetrahedral intermediate. So what's going to happen, it's going to reform the carbonyl group. So it's going to give 2 electrons to this bond to form a pi bond, and then this group is removed and you form an aldehyde. And then with another molecule of aluminum hydride, H minus, so the aldehyde can be reacted with another hydride, react with the carbonyl carbon, pi bonds open, forms the alkoxide ion, add the acid and then become primary alcohol. I just showed you this mechanism, but it is a little more than the mechanisms that we have seen. So those of you who are interested about the mechanism, it's good for you, but otherwise it's okay if you don't totally get this mechanism. But it's understandable, it's doable. What I'm saying is you will not be checked on this during the exam, okay? Okay, so these hydrides, like the lithium aluminum hydride, so these reagents can also react with other types of carbonyl compounds. For example, amides. Amides is carbonyl group with NH2. They can react with lithium aluminum hydride. Again, the hydride is the nucleophile. So hydride will add on to the carbon and then it will reduce to a primary amine. And this is another amide, lithium aluminum hydride with water. It's gonna give you CH2 group. You see your product doesn't have any alcohol. It reduces this carbonyl group to CH2, reduces carbonyl group to CH2. Carbonyl group next to the amide group, nitrogen amide group, reduces to CH2 group, okay. And this is the mechanism for that. Again, it is there for you to refer if you're interested how it happens, but I'm not going to check on you guys for the exam this mechanism, but just know that if you have an amide group, carbonyl group can reduce to a CH2 group with lithium aluminum hydride, and the second step adding water. Excuse me. Okay, so we do have some more reduction reactions. We'll talk about this in the next session.